So in this question, two students carried out an experiment for a nitration of methyl benzoate. Like this is a methyl benzoate, like one carbon group, so methyl, and when benzene ring is attached to C double bonded with O, so it's an ester of benzene. That's why it's called benzoate. So nitration of a methyl benzoate is done. Nitration means like addition of nitrogen and oxygen. The following outline procedure was used. So first, 5 cm cube of sulfuric acid into a two neck round bottom flask, and it cools to 5 degrees. And we slowly add 3 cm cube of a methyl benzoate to sulfuric acid and keep the temperature as 5. Because if the temperature is higher than 5, what might happen? Then multiple nitration, like multiple substitution might happen or occur. Like in NO2 is attached with one of the carbon, it might attach with multiple positions it can attach. That's why to prevent multiple nitration, we did not heat, we just try to keep the temperature around 5 degrees. Then place 3 centimeter of concentrated nitric acid and cool it to 5 and slowly add sulfuric acid while the mixture keep at 5. And this is a nitration mixture. Then pour the nitrating mixture into a tap funnel, which is placed vertically in a round bottom flask, and put the flask in an ice bath. Place a thermometer in the other neck. Then add the nitration mixture, a drop at a time, to the mixture in the flask and do not allow the temperature to rise above 5. Then when all the nitrating mixture has been added, leave the mixture for about 10 minutes. Pour the mixture from the flask to a small beaker containing a crushed ice. Then filter the impure solid methyl 3 nitrobenzoate under a reduction pressure. Then recrystallization happen. Then dry them. Find the mass of a crystal and determine the melting point of the crystal. That's how. So this product, the final product, is solid. So give a reason. The first one. So we have to state with a reason here. Why benzene should not be used in the school lab. The main hazard of using a benzene is like can cause cancer. The compound benzene is can cause a cancer. That's why it should not be, or it is a toxic, can cause cancer. That's why it should not be used in the lab. It's not explosive. It is toxic. Is a main. So this compound benzene is toxic, and it can cause cancer. Give a reason why the temperature is kept low in step 1 and step 2. So as I mentioned, first thing, as a reaction between sulfuric acid, it's a highly exothermic reaction is there. And so it is a highly exothermic reaction. As a result, it will prevent multiple nitration or hydrolysis of the ester. Because it's an ester, esters can be hydrolyzed to carboxylic acid and alcohol. These are the two main reasons we are keeping a temperature below 5. Then complete a diagram to show the operator's setup and the end of stage 3. The operator setup, we have to pour nitric acid mixture into a tap funnel and then place it vertically round bottom in the round bottom flask and put the flask in an ice bath. So you have to draw this and place a thermometer in another neck of a flask. So this one is shown. We just have to complete the diagram. So there is a tap funnel. So this side we should have a tap funnel. So there will be a tap here, and one side will have a thermometer because they mentioned already, and this should be in ice bath. Like crushed ice is there, and then the reaction mixture in this flask. It should be labeled whenever you draw. You should draw the label diagram. Then the molar mass of a methyl 3 nitrobenzoate is 181. However, a small amount of a product with a molar mass of 226 is also formed. If the temperature of a is allowed to rise above 15 in step 4, suggests the structure possible, like how much mass has increased if it is 226 minus 181, that is 45. So means the total mass which is increased, like what might happen, why the mass has increases. As I mentioned, because we want to prevent what might happen, maybe multiple nitration happen or occur. Like this was a product which we want only um, one NO2 group is there. But what might happen? Maybe another NO2 is attached. And when another NO2 is group is attached, like nitrogen is 14 and oxygen is 16 multiplied by 2 to 32. So 14 plus 32, that's equal to 46. But when 46 enter, like this total is 46 enter, one hydrogen will leave. So what is the total change in the mass? That will be by 45. So what might be the other product which is formed? As which is having a mass of 226. So that might be due to the multiple substitution. The C double bonded with O and CH3 is there. This was NO2 and this was NO2. So when one hydrogen and name, now how to name these benzene rings or the structure. So we count these position, like this is the first position and second, third, fourth, fifth. Or you can count other way around. 1, 2, 3, 4, 5. So third position and fifth position, we have a nitro group. So 3, 5 dinitro because nitro group, 2 nitro groups. And because of this, uh, first we have a methyl, like this group is a methyl, and then 3, 5 dinitro benzoate. So this one, because of this one, it is methyl. And then in a benzene ring, we have third and fifth position nitro group are attached. So 3, 5 and 2 nitro groups are there. So we say dinitro. And because of this benzene attached with ester, so that is called benzoate. When a benzene ring attached with C double bonded with O and O, that's called benzoate. So it's methyl 3,5 dinitro benzoate. Then give a reason why methyl 3 nitrobenzoate is separated from a reaction mixture by filtration under reduced pressure rather than normal filtration. Look, when we do a reduce, what is the advantage here? When we filter under a reduced pressure, it will be like it will produce a dry solid and it will increase of the filtration, like it will be more efficient. Usually normal filtration, what we do, we allow it to under the normal atmospheric pressure. Like here is a conical flask placed, funnel is there and a conical flask and there's a filter paper. So gradually the filtrate will pass through the filter paper and we collect and a solid, but this won't be a dry solid. uh, when we reduce under a high pressure, that is known as the Buchner funnel, which is having a side arm here. So when we reduce, like here is a pump is connected. So when we reduce the pressure from inside, the atmospheric pressure, the outside pressure is more. So what is the advantage of reduce under high pressure, filtration under reduced pressure rather than normal pressure? This will be fast filtration and this will produce a dry solid. So, so why it is done? So produce a dry solid or increase the efficiency of filtration or filter it fast or quickly. Is it clear? Then student one describe how to carry out a recrystallization. Recrystallization is same like crystallization, but we crystallize again. The substance is crystal, then we dissolve, and then like example, say sodium chloride is, so we have a crystals of sodium chloride, but there are impurities present. Some are soluble impurities, some are insoluble impurities. So what we do or what is done, if you want to separate, like some of the impurities are soluble and some are insoluble from the crystal, so we will dissolve and then we will filter and then we recrystallize, like form the crystals back again, so that the soluble impurities remain in the filtrate and only crystals will form, and insoluble separated by. So first what we did, we dissolved the impure solid into hot methanol. Why hot methanol? So that the maximum will dissolve. That's why it is hot. Then cool the solution in an ice bath. So when we cool down the solution, separate the crystals by using a suction filtration. So usually when we want to separate the soluble impurity, we use this one. And then dry the crystals with a solid anhydrous sodium sulfate or in a stopper boiling tube. So recrystallization normally used to obtain the pure crystals from soluble impurities. The student's description of a step A omitted an important detail. State how method A should be changed and justify your answer. Like what detail is missing? We should take a minimum amount of hot methanol, because if we take large amount, as a result, what will happen? Uh, Maybe it won't crystallize. So when we take a hot solvent, we should take a minimum amount, very small amount of a hot solvent. Otherwise, if I take a very large quantity of a hot solvent, so all the solid will dissolve and it will not crystallize. And the second is so that when we do crystallization, maximum amount will crystallize. So the point you will mention here, what is missing? It should be minimum amount of hot methanol should be used. So crystals can form on cooling. Then describe what the student should do after step A and before carrying out step B. So what should be done between step 1 and step 2? Like step A and step B. So as I mentioned, we should use, like we should filter it to remove any insoluble impurities. Like as I mentioned in the beginning, say we were having a crystals. So these are the crystals, and these crystals have some soluble impurities, like blue spots are representing soluble and red is representing insoluble. So when we add a minimum amount of solvent, the moment we add minimum amount of solvent, both the crystals and the soluble impurities will dissolve and insoluble impurities will still be there. How we separate these insoluble impurities? By filtration. So by filtration, we'll remove them and we will have a solvent. And from this solvent, When we do crystallization, when we cool down, the soluble impurities remain dissolved and the crystals will appear on cooling. So the process which is missing here, that there should be a filtration. And from filtration, another part. Give two reasons why step D would not work and describe how students should dry the crystal. So the thing is why step D does not, because it's not forming a water vapors. Sodium sulfate, these are the drying agents, and drying agents are usually used to separate the moisture. So both, like example, if I have a solid here and I use anhydrous sodium sulfate, so both are solid, it won't react easily. It won't take up the moisture directly. So what we should do to carry out this process effectively, we should dry like using a tissue. When solid, we want to dry solid, we don't dry those solids by using the drying agent. We remove the moisture by drying agent. So here, why it is not useful to use sodium sulfate to remove the moisture from the crystal? It's because drying agents are used to absorb the moisture, like they cannot absorb these water molecule on the surface. So what we should do, we should, both are solid, one thing, both are solid, it won't work easily, effectively. So we should use a tissue paper to dry the solid. Or desiccator can be used, or leave in the hot place or oven to dry. Then student who carry out the recrystallization and obtain 2.2 grams of a methyl from 3 cm cube of a methyl benzoate. Calculate the percentage yield. So if you have 3 cm cube of methyl 3 from 3 cm cube of a methyl benzoate and the density is there. So first we'll find the mass. Methyl benzoate density is there. Methyl benzoate volume is there. So we'll find mass is equals to density times volume. That is 1.09 times 3. This will give us the mass of methyl benzoate, which is, when you multiply, it will be 3.27 grams. And then you will take the ratio of the mass of methyl benzoate and 3 methyl benzoate. Their molar, because the ratio is 1:1 according to mole. So if the ratio is 1:1, it means the molar mass ratio will be same as well. Like the mass ratio will be same as the molar mass ratio. As you can see, 1 mole of a methyl benzoate, we are forming 1 mole of methyl 3 nitrobenzoate. So ratio of the mass will be same as ratio of the moles. Sorry, ratio of the molar mass will be same as ratio of the mass in gram. So after getting the mass of methyl benzoate, we'll take a ratio for methyl benzoate to methyl 3 nitrobenzoate. It is 136 to 81. So 3.27, it will be X. Just cross multiply. This will give us what mass we should get after taking this ratio. So theory suggests we should get about 4.35 grams. But practically, we are not getting 4.35 grams. Practically, we are getting 2.28. So to get the percentage yield, is a practical value 2.28 divided by theoretical value into 100. When we multiply, we'll get the percentage yield, which is about 52%. So practical divided by theoretical multiplied by 100 will give us a percentage yield. Practical value of a product is given in the question. This was the practical value given in the question. Theoretical, we work out by using the ratio of the mass. Then in part H, the melting temperature of a methyl 3 nitrobenzoate is 77. Describe how students should use the operators shown in the diagram and range of a sample of the crystallized. is methyl 3 benzoate. So you can see a capillary is there. Uh, this is also known as the melting point apparatus in a small capillary in a small tube, which is sealed from one end. And sometimes they ask how we seal the capillary. So how we seal the capillary, we heat the capillary tubes are usually open from both ends. Like there's an opening in both ends. How we seal one of the end, we supply the heat energy and just close that. Like we supply the heat energy and then close the one of the opening so the eye this will melt and close this capillary tube. So capillary tube is one side we close, one side it is open. And then we add a sample, a solid sample is added, and then we place in a beaker, a stirrer is there, we supply heat energy. So what we'll do, we'll supply heat energy, use a stirrer, like heat the water gently and use a stirrer so that the uniform transfer of heat. And then we'll observe a temperature at which the solids start to melt. And we'll continue, like when it start to melt, we'll measure that temperature, and when it completely melted, we'll measure the final temperature. That will give us, because usually what happens, practically it should melt at a specific temperature. Sorry, theoretically it should melt at a specific temperature, but practically we might have a range. Like when the solids start to melt, when we are looking, solids start to melt, maybe it was say 70. When it is completely melted, we observe the temperature was 72. So we will heat gently and stir. Then record the temperature when the solids start to melt. And record the temperature when all solid turn into liquid. So this is always the case whenever you're using a melting point apparatus. And one more thing, the liquid which is used here, like in this case, we are using water. But what is a suitable liquid? First thing, the liquid should be unreactive. Second thing, the boiling point of the liquid used here should be more than the melting point of the solid. Usually organic solvents have low melting point. So boiling point of the liquid which we use in this beaker should be more than the melting point of a solid. Otherwise, if this liquid was having a low boiling point, most of the liquid will evaporate and it won't be accurate. If the boiling point of a liquid is lower than the melting point, so we won't reach the melting point, and before that, all the liquid will evaporate. And it should be a clear liquid so that we can easily read the scale, the thermometer. So these are some points which are related to the apparatus. Is it clear?